so here we go. Somebody tell me what a transformation is. You should have went over this in geometry. Yes. Anybody else know what a transformation is? Yes.
One thing
Carlos.
to another.
Isn't that like the reflections?
Yes.
In the slide?
And whoever else said that, move from one place to another. Yes. So there's a reflection. What's it mean if you move from one place to another? That's a
translation.
Slide or translation. That's the right word. Good. What else did we have? Dilation and a rotation. Good. Okay, so we did that in geometry with shapes. Hey, Carlos, can you give him what? Yeah, right there you go. That's for the whole chapter.
Okay, I was like.
Okay, that's the whole chapter. Okay, so instead of this time using these shapes, we're actually going to take expressions and equations and we're going to move the whole thing. All right, so go ahead and hit enter. All right. So this is basically what you just talked about, okay? We can do dilations, we can do flips, rotations, slides, and mirrors. Okay, all that, if you want to write it down, you can. Okay, so it says a transformation is a change in the position, size, or shape of a figure. A translation or slide is a transformation that moves each point in a figure the same distance in the same direction. Okay, so everything moves the same amount of distance. Okay. So far, so good? Oh, wait, I still see some people right. All right, go ahead and hit enter. All right. So let's look at these and let's talk about them first, okay? There's a couple different methods that we can use. We can use the counting method or we can manipulate the points, okay? The X and Y values. All right, so let's talk about our graph. Let's think about what we know about the graph, okay? What are the values on this line? Are they X's or Y's?
X.
X's, good. What about this one?
Y.
Y's. Which one of these is vertical and which one is horizontal?
Y is vertical,
Okay.
X is horizontal.
This is vertical. This one is horizontal. Good. Okay, so good. So far, so good. Now, if I start anywhere on this graph and I go down, whether it's there or there, are my values getting bigger or smaller?
Your Y value is getting smaller.
They're getting smaller. So anytime I go down means subtract. What about if I start and I go up? Anywhere.
They're getting positive.
Good.
Positive.
So up means I'm going to add.
Yeah.
Okay, so let's do the other direction. Let's talk about left and right. What if I start way over here and I go to the right? Am I getting bigger or smaller?
Bigger.
Bigger, so I'm going to add. What if I start here and I go that way?
Smaller.
Smaller, so I'm going to subtract. So left is subtract, right is add. Up we add, down we subtract. So let's look at this one. The original point is the blue dot. Somebody tell me, they don't need to, it's right here. Okay, so here's those original coordinates, okay? We graph those as X and Y. We go over 2 on the X, down 1 on the Y. All right, if I move that thing left, I can do it 2 different ways. I can plot the point and I can count. 1, 2, 3, 4. Does everybody agree?
Mm-hmm.
Yes. If you don't like to do that, would we say anything that goes left is subtracting, and left and right would be which one, the X or the Y? The X. So I could do minus 4. What's 2 minus 4? 2. So negative 2, negative 1. Does that look like the coordinates right here?
Mm-hmm.
Yeah. You decide whichever method you like the best. Both ways will get you the same answer. It's got to be up to you to decide. Okay? Now, on this next one, they did 2 things. What'd they do? They went
Right.
Yes.
So did you not subtract it from the second one because?
Did we go, so this is my Y,
Okay.
and the Y's go up and down. Did they have us go up and down on this one?
No.
So does that one change at all? No, so it'd be just like adding or subtracting 0. Okay, good question. All right, let's look at this next one. All right, so on here they want us to go right 2 and up 3.
So you could add 2 to your x and add
Okay.
and subtract and add 3 to your x or your y.
Absolutely. Could I have just plotted that point and said, hey, right 2, 1, 2, up 3, 1, 2, 3? Yes, I
But
could.
if you don't have a graph or something.
Exactly, and he's exactly right. What if I don't have any graph paper at home and I don't want to make all those little tiny boxes? He's exactly right. So what is 2 plus 2?
4.
4. What is negative 1 plus 3?
2.
2. And we do have calculators back there if anybody's having problems with the positives and negatives. Okay, 4, 2. Did that get me the same spot? So we're good, right? So we can use whatever method that we like the best. Okay, so far so good. Do we need to do another example using these down here? Do you guys think you're good?
Good.
Good? Okay, go ahead and hit enter. All right. This is exactly what I just told you. So I give you a big fancy chart, and they show you how to throw that in there and add or subtract it or whatever. Yes, you can grab your Chromebook. You're just going to be on camera. Smile for camera. Okay? All right, so this is exactly what I told you. They show it a little bit different. They show it from left and right, whereas I like to stack them. Okay? It's whatever you like. Go ahead and hit enter. A reflection. What did we say a reflection was?
Yeah, just on the opposite
Good.
side.
Good. Both of those are right. It's like a mirror on the opposite side. Okay? So, if you were in my geometry class, I'm sure you heard me say this like a million times. If I reflect over the x-axis, I negate the y. And if I flip over the y, I negate the
X.
That's the rule. Or, can I just look at this one here and notice it's 1 away and just go 1 away the other direction? Yes. Is there anything wrong with that?
No.
Okay, here. This one is 1, 2 away, but now I can go to the opposite direction. Is that okay?
Yeah.
Yes. Or I can take those points and I can negate. If I flip over the y, I negate the x. If I flip over the x, I negate the y. Okay? Go ahead and hit enter. All right, so let's look at this one. You're going to have some like this on your homework. This is the answer, but let's wait. Don't look at this for a minute. We're going to check our answer. Are there any set points on this picture?
Well, no.
But could I make some set points?
Yeah.
Like, is this exactly at a perfect point? What's that coordinate?
-1.
-1,
0.
0. Good. What about this one? Is that one at a perfect spot?
+2. 0.
Okay, he says
2, 0.
0, 2.
Oh, 0,
There we
2,
go.
you're right.
What about this one right here? Good. 4, 2. Now do I have some points to work with? Yeah, let's do one more. Let's do this one that's right here. It's a perfect point. What's that one?
-1 or -2, +4.
Good. -2, +4. Okay. So this is what you're going to do in your homework. This is going to make it easy for us to move this around. What's the first thing that it's asking me to do?
Move it to
Okay. Now that I have these points on exactly...
You can just move the points.
Absolutely. Why not? Well, I'm going to switch colors. Let's use green. So can I just go down 1, 2? What about this one?
2.
1, 2. 1, 2. 1, 2. Now all I gotta do is what?
There's another one.
Just connect them, right? Good. So this one goes here, there. There we go. So far so good, right? Does that look like what they did? Now, could I do this? Could I make a T-chart? What's a T-chart, by the way?
a plot that looks like a
Good. I have my X's and my Y's. Could I take this point and write -2, 4, -1, 0, 0, 2, 4, 2. Now, if they were wanting me to go down, would that be the X's or the Y's?
Right.
Y's. And if I'm going down, am I adding or subtracting?
Subtracting.
Could I just go like this? And that would equal 2. That would equal -2, 0. Did that give me the same new coordinates?
Yeah.
Okay, so you decide which method you like the best, okay? So this is a T-chart. You can use whichever method you like. All right, so so go ahead and hit enter. All right, this one's reflecting. Okay. I wish I would have not put the both colors. Okay, let's start with the blue one. Okay, the blue one is the original. Again, I can pick points here, here, here. Okay, I can pick those, and the only reason I chose them is because they were exactly at the intersections, okay? Now, which axis did they ask me to reflect this across?
The Y.
The Y. Where's the Y? Up and down. Okay, so let's start with this one. How far away from the Y is this one?
2.
2. So I need to go 2 in the next direction. So 1, 2, 1, 2. So far, so good. It landed on the right one, right? What about this one? How far away is it?
1.
So I go 1. How far away is this one?
0.
Not at all. So it's just going to stay. Do we all agree?
Mm-hmm.
Okay, what about this one? How far away is this one?
4.
4. So I need to go 1, 2, 3, 4.
Oh, so you gotta count from the y-axis, not the other point.
Yeah, you could count here at 1, 2, 3, 4. So it takes me 4 to get there. So now I need to go 4 away.
Okay.
Yeah, good. Good question. Okay, so far so good? All right, go ahead and hit enter. All right, we're going to talk about stretches and compresses, and I think it's easier to visualize it, okay? So everybody in here knows which way is vertical and which way is horizontal. If I have a piece of taffy and I stretch it, is it vertically? Is it going to get fat or skinny?
Skinny.
Skinny. But what if I take that taffy and I pull it apart this way?
It's gonna get
Like I
skin.
It's still gonna
It
get.
just kind of,
take it, like if it's, yeah, it's gonna get wider. Yeah, so think of the taffy, if it's this, like the Lappy taffy, and I take it and I pull it like this.
But
Yeah.
I mean, if you do it like that and then just turn it, it's the same.
No, but we're not gonna turn it,
Oh,
just
I'm
one or
just
the
saying.
other.
Yeah.
just like it's
Okay.
still, the piece of taffy is still saying vertical. And you're going to pull it like this
And I'm
way.
gonna pull it,
This way is going to make it
horizontal.
skinny, and then horizontal is going to make it
I
just
thought about
matter.
making it bigger.
okay? Now, what if I have that same piece of taffy,
It's like,
okay, I have that same piece of taffy, and I take it and I vertically compress it.
It'll get like
Will it get fat? Will it spread out?
spread out.
Okay, what if I take that same piece of taffy and I take it and I squish it together like this, horizontally?
it shrinks.
Yeah, it's gonna get really skinny and long. Okay, all right, so let's look at this. What kind of shape is this one?
A U?
Say it. What shape is this?
I did not
A
say.
U?
Somebody said
A
it.
U?
It's a parabola. Okay, so when we think about stretches and compressions, yes, a parabola.
Did you find
Okay,
it?
this is a parabola.
Let's see what's inside.
We will work with these a lot. You'll get used to that word. Okay, so let's look at this one. I need a volunteer. Come on up, Carlos. All right, so Carlos. All right, so what I want Carlos to do is a vertical stretch. Hold on, I'm gonna just adjust this just a little bit here. Okay, so Carlos is gonna do a vertical stretch. Which way is vertical again?
Straight. Up and down.
Up and down. Stretch it. So I want you to grab those two, the pink and the yellow, and I want you to vertically compress it.
Wait, vertically compress it?
Vertically stretch. Vertically
Okay.
stretch. I'm
Like
sorry.
That?
Yes. Okay. Good. What happened?
Shrank.
Turn it to
Became
What is that?
skinny. Okay. Look. So watch. If you can remember this one little trick, you can figure all of them out. Okay. So vertical stretch. What else has those same initials?
person.
Velocity versus speed.
Say it again. Victoria's Secret. Aren't usually the Victoria's Secret models skinny?
Mm-hmm.
Usually, right? So, Victoria's Secret is skinny. It makes my graph skinny. All right, Carlos, you pick somebody.
Seth.
That's a good one.
Oh, I'm sorry.
Victoria's Secret.
Yeah.
He didn't pay attention. You can do it.
Okay?
He never paid attention.
Is this open?
All right. So this time, all right, he's going to do a vertical compression. So vertical. Vertically, he's going to, compress it, squish it down. What happened to my parabola? Did it get fat or skinny?
Fat.
Fat. So instead of Victoria's Secret, we got Victoria Chunky.
Victoria, yes. Oh, sorry, BC.
Okay?
Fat shaming, and I'm fine with it.
Okay? So all we did is vertically. All these moves were vertical moves, right? Okay? All right, so let's start here back to normal. All right, pick somebody.
Are you serious?
I can't do it.
He's got one arm. You have to do one at a time then. All right, so listen. Is it Bryce?
Yeah.
Bryce. Okay, so Bryce is going to do a horizontal stretch. So he's going to horizontally stretch it. So,
Yeah.
It's like a diaper.
okay, good.
Smoking.
Okay, so what happened? Did it get fatter or skinnier?
Fatter.
Fatter. Okay, so horizontal stretch also gets fat, which was the same thing as what?
Hamster.
Yes, vertical
Nice.
compression.
Good
So
answer.
listen, let's keep going. Do what?
I said the hamster.
And sandwich.
Okay, pick somebody, Bryce.
There's like a lot of stuff.
Alina.
All right, Alina, you are going to do a horizontal compression. So horizontally, we're going to compress this thing together, and let's see what happens.
Will the following students please see Mrs. Nevels, Aiden Reyes, Gabe Hager, Tanner Coolin, Logan Junkins.
All right.
Thank you.
Seth, have a seat. Let's get in your seat. All right, listen. So what happened? Did it get fat or skinny?
Skinny.
Skinny. All right, Britton, that's not going to be a good spot for you.
Sorry, Brenton. Brenton got called out live.
You were listening to the conversation, not my conversation. All right, so listen. Hey guys, are we listening? Okay, so here's the key. A vertical stretch and a horizontal compression are going to cause the same effect. Now we're going to get them different ways when we start manipulating those formulas, but they're going to give us the same effect on our graph, okay? Whereas a vertical compression and a horizontal stretch are going to give us the same thing. So you have to have a stretch with a compression and a compression with a stretch. And if you can remember that Victoria's Secret is skinny, you can get all the other ones from there, okay? Because this is stretch, so it has to have a compression. They're both skinny. That leaves Victoria chunky, and she's a compression, so it needs a stretch. Okay? So far, so good? Yes. Do you have a question?
No wonder girls have body dysmorphia.
Yeah.
Go ahead and hit enter. Okay. All right, so let's look at this. Now, on this next one, they're wanting us to actually do this. They're wanting us to actually create the vertical stretch or the horizontal compression, whichever one they give us. They gave us this big fancy T-chart. We don't need that. Where do you think they came up with these points?
On the thing.
On the graph. So let's just pick something easy. This one's exactly on a point. This one's exactly on a point. That one's exactly on a point, and so is this one. With 4 points, we should be able to move this graph pretty decent, don't you agree?
Mm-hmm.
Yeah.
Okay, what's the coordinates of this first one?
-1, +4.
-1, 4. Okay, when I put this into my T-chart, where do I put it?
1 on the X, -1 on the X, and then 4 on the Y.
Good, okay. What's this one?
0, 0.
Is it 3? It is 3. Sorry.
Sometimes it's hard to tell.
It is, especially from back there.
Mhm.
0, 0. Okay, what's the coordinates of that one?
+2, +2.
2, 2. All right. What about this one?
5, 2.
4, 2.
Unless you're going to 4. It's at 5, 2.
I went over one.
Yeah.
Okay. So this is where I come up with the numbers for my T-chart. Okay, this is where I get my X and Y values. So Seth, can you tell me what they're asking me to do here? What are they asking me to perform?
Stretching and compression. No. Yeah.
But
Stretching
what
and compression.
specifically?
Multiplied by 1/2.
They're asking me to perform
Perform a horizontal compression
Okay.
by a factor of 1/2.
Okay, by a factor of 1/2. Good. Okay, that's important. Okay, if it's horizontal, what is that? Is that the X or the Y?
I'm not.
Horizontal. X. Okay, so I'm going to multiply the X by what?
1/2.
Sorry,
Okay, so I'm going to take all of these and I'm going to multiply it by 1/2. Oh, now I see why they used 4. Why do I want to change this point and move it over to 4?
Because
It's an
it would have been
even number.
2.5.
Good, because 4 is an even number. And there's nothing wrong with that in the homework if you do that, if you want to change it. Okay? So what's half of negative 1?
0.5.
0.5, negative
Just
0.5.
Positive? Okay, good. Negative 0.5. Okay. What's half of 0?
0,
Okay, what's half of 2?
1,
Let's squeeze it in there. What's half of 4?
2.
Okay, so do you agree that my new coordinates are negative 0.53? Do you agree?
Mm-hmm.
Where'd I get that?
Because you took the x by half.
Good, that's my new x. Did this one change?
No.
No. My next one would be 0, 0. 1/2, 2. And 2, 2. Okay? Does it look like they've graphed these like that? We're going to go ahead and do it on ours. Okay, so negative 0.5.
What makes it 1/2 2?
3. Say that again.
What makes the third one 1/2 2? I thought
Makes
it would
the
just
third
be
one.
because isn't it just half of
It would
2?
be 1.
Yeah.
Thank you.
Welcome.
I had it written there, but I just didn't write it right. I wrote that part.
No,
Sorry.
yeah.
Good call. Good call. 0. Okay. 1, 2. 2, 2.
So it just shrunk
Yep.
a lot.
Well, and what we say about
It just compressed.
what did we say about a horizontal compression? It was going to do what? If we take it and squish
Skinny.
it together,
Skinny.
going to get skinny. Did we get skinny?
Yeah.
We did.
Give
Okay.
me some horizontal
Now,
compression.
what if I ask you to do a vertical stretch? Which one of these would I manipulate?
The y.
The Y's, because it's vertical.
Mhm.
Good. Okay, because that's what you're going to have to do on your homework. Okay, go ahead and hit. Any questions on this first? We good? Okay, hit enter.
Oh.
And we're good. All
Those are
right, go ahead and
lovely.
stop that for me.
Bye guys.
Obviously, it's